This example is to do with comparing data. So the example we have is that from the large data sets, we've got some information to do with Heathrow and Leeming to do with the mean temperature. So for Heathrow, we're given it as summary statistics. So we're told the sum of x is 562.0, and the sum of x squared is 10,301.2. So we're going to calculate the mean and standard deviation from those. And then later in the question, we get given the mean and standard deviation for the temperature at Leeming, and we're going to make a comparison between the things that we work out. So important, when you're doing a comparison, you're really going to compare one measure of location with another. So we're going to compare the mean for Heathrow with the mean for Leeming and make some conclusion. And then we're going to compare the standard deviations, because the second comparison should be to do with comparing a measure of spread. So in this case, it'll be the standard deviation, but in another example, it might be that we're using in the interquartile range, or we might use the median instead of the mean. Typically, we want to do that if there are extreme values. So anyway, in this case, we want to calculate the mean and standard deviation for, and then we'll actually be able to use that. So by using the summary statistics, we've got the mean is going to be x bar will be the sum of x over n. So sum of x is 562. And we're going to have to assume that we're using 31 days, I guess, because it's just told it's during August. So if we assume that's for all 31 days in August, n is going to be 31. So we'll divide that by 31. And we get 18.1 from that. In fact, I'll put more of the decimal places down because we'll be using this number later on. Anyway, we've got the mean at least. Then we also want to get standard deviation. So the standard deviation of x is going to be the square root of the mean of the squares. So the sum of x squared over n. Subtract the square of the mean, which is what we calculated a moment ago. So that's going to be the same as doing square root of 10,301.2 divided by 31, subtract the 18.129032226 squared that we calculated a moment ago. So feed that into our calculators and we'll find out what that is. And I'm getting 1.91 for that. Okay, so I've got mean and standard deviation for Heathrow now, which is what we were looking for. And part B is where we're going to do the comparison. So if we compare the means first of all, we've got the mean for Leeming is 15.6, that was given in the question. The mean for Heathrow is the 18.1. So what we can say is that the mean temperature for Heathrow is 18.1 compared to degrees to 15.6 degrees for Leeming. So that's suggesting Heathrow is warmer on average. And then we also want to compare standard deviations. So we've got a standard deviation of 2.01 for Leeming, 1.91 for Heathrow. So we can say that the standard deviation for Leeming is slightly higher than for Heathrow, only slightly actually. Suggesting a slightly more variance in the data for Leeming. So we've got comparison of measure of location, so comparing the means, and a comparison of a measure of spread, which was comparing standard deviations, and that's what we needed to get.